Now we're looking at an example where we're trying to find where this is discontinuous and then showing that or which rule or condition is not satisfied for this function to be continuous at a particular value. So if we look at this, I hope that you guys can tell where this graph is discontinuous. So this is discontinuous. I can see when x is -1. I can tell it's discontinuous because there's a jump here. Maybe we can go ahead and define why it's discontinuous. So if I looked at f of -1, it does exist, right? We would go and x is -1, we'd go over to where the solid circle is, and there's a solid circle here. So that y value here is 3. If I look at the limit as x, though, is approaching -1 on the left of this function f of x, so coming in on the left-hand side, so go to the piece of the graph directly to the left of -1, follow it, and we're trying to see what y value are we getting closer and closer as we approach this -1. And so notice this is 3. But if I look at the limit as x is approaching -1 on the right-hand side, so coming in on the right-hand side of -1, so there's more than one piece on the right of -1, but I need to go to the piece of the graph directly to the right of -1, so this one. As I'm coming in, though, my y value I'm getting closer and closer to. Let's just estimate this. It's an open circle. It's not there, but it's getting closer and closer to, let's say that's 0.75. So the condition that doesn't hold is that the limit does not exist. So limit as x is approaching -1 of f of x does not exist. And again, it's because left and the right-hand side have to approach the same value. So this is the condition that doesn't hold. So we can say it's discontinuous. At x equals -1. If you look at another place where it's discontinuous, so notice here at x equals 0. So it's also discontinuous at x equals 0. And if you look at this, and we're showing one of them already doesn't work. Look at f of 0. If you go on here, when x is 0, I have an open circle here. So it's not defined there. And if I'm coming in over here, this is getting closer and closer to, it's a vertical asymptote on this line. So it's never going to actually touch or cross. So f of 0 is undefined. So really, if you can show one of the conditions doesn't hold, then we can really stop. But I just want us to get used to and do a little bit of a review of the limits. So let's just look at the left and right hand side of that limit as x approaches 0. So if I look at the limit as x approaches 0, on the left of f of x, so if I'm coming in on the left-hand side, I would be following this graph. And notice it's not going to any one y value. The y values are getting larger and larger and larger. And so it's never going to approach one y value at all. And so we would say that this is equal to positive infinity. So it doesn't exist because it's not approaching any one y value, but a lot of times we like to say, where is it going? And the limit as x approaching 0 on the right of f of x, so coming in on the right-hand side, the y value we're getting closer and closer to on the right-hand side is 3. So this is one of the condition that doesn't hold for continuity. The other one that doesn't hold, right, is the limit as x approaches 0 of f of x has to exist, and it doesn't. Oops. And one more. Looking at the graph, I can see it also is having problems at x equals 1. So notice that the condition of f of 1 holds. So discontinuous. If I look at f of 1, there is a solid circle in the graph, and that y value is 2. So f of 1 is 2. I can see that my limit actually exists as I'm coming in on the left and I'm coming in on the right of 1. Notice I'm getting closer and closer to the y value of 1. So the limit as x is approaching 1 on the left of f of x is the same as the limit as x approaches 1 on the right, which in our case is equal to 1. Those two conditions hold, but the condition that doesn't hold is that limit as x is approaching 1 of f of x is not the same as f of 1. So here is the reasoning behind, or why we can show that it's discontinuous at x equals 1. Okay, so looking at a graph, you should be able to tell where it's discontinuous, and then you should be able to explain which of the conditions of the 3 do not hold. So it has to exist at that value, the limit has to exist, and that limit as x approaches a of f of x has to be f of a.